And Xbox needed it not only in real time, but 10 times real time. They wanted to run it on 10% of the CPU. So Xbox needed their hard requirement to make it an acceptable entertainment experience, let alone using it for Windows and all the other amazing experiences that we're starting to see today, is they wanted to run it for all sorts of motions, all sorts of users. They wanted to make this technology available, if you remember, to expand their market, to make it accessible to all sorts of different people. And that means people of different sizes, different shapes, all sorts of different attributes of people. So all motions, all agilities, 10 times in real time for multiple different body types. They did have a low-cost 3D video camera, a depth camera, a technology license from PrimeSense. That was a key factor in this, but the software is really where the magic happens. And you can learn about this software today. I won't spend time lecturing you today on the details of this algorithm. You can go and read the paper if you haven't already. It won Best Paper Award at CVPR, the big computer vision conference in Colorado this past year. These are the authors of the research and the technology in Xbox that designed the vision system in Kinect. Again, it's not just about the vision system today, but the vision system is a really nice piece of Kinect. And so you can read how we solved that problem and made some breakthroughs in that technology. There's the paper there, there's some supplementary information as well, and a video explaining that work. And I think it's testament to not only the quality of that research and the success of this as a product, but also this is the latest research. This is high-end research. And it's all part of the remarkable story of Kinect. There's some of the best researchers in the world here. They won Best Paper Award about this technology. I won't go into the details, as I say, for time, and I'm sure you can go read this paper and understand it better than I can explain it. But I do want to highlight, for those of you that don't have time to read the paper, or maybe not interested enough, one of the interesting things, though, I'd like to tease out is a curious innovation that happened in designing this algorithm to be very high speed, working on 10% of the CPU. So what the breakthrough in Microsoft research was, the researchers there on the list of that paper, they had done object recognition research, not so much body tracking research. Now the thing about body tracking is that it's natural for you to think that body tracking is about a time sequence. I'm moving in time, my body is moving, I'm tracking a body over a time sequence. But that's not how the algorithm works. The algorithm works just on simple object detection, object recognition. And it uses a per pixel classifier. So all that means is I'm looking at the depth image, interestingly, only the depth image. Looking at the camera that's seeing only the z-axis, the distance from the camera to the person or multiple people in the room. And for every pixel, it is taking a classification measure of what the probability is of that pixel, each pixel, being part of a human body, and which part of the human body. And that's a pretty amazing breakthrough, that you can do this human body tracking with just looking at the scene using object recognition, object detection, classifying per pixel, not even looking at video. It's just looking at each video frame as a single picture. So the algorithm works if you didn't have a video. The algorithm works just if you have a single picture. Of course, all you get then is a table of numbers showing what the probability is of a pixel being part of some part of the body. But that's essentially how the vision algorithm works. It was a big breakthrough. One of the neat things is it's fast. And so you can get this not only at 10 times real time, but the research paper at CVPR, I think, explains their tests showed this could work at 200 times real time on a regular PC. It's a classifier, it's artificial intelligence, it's a machine learning algorithm. You therefore need to have a big training set. For those that understand about machine learning, this is typically the way that you use this technology. And so in practice, while you can come up with this cool algorithm, to actually make it work, you need to do a lot of work. And that's hard work sometimes. I have to go out to the field, collect thousands of images from tens of thousands of homes with real people in it, because I need to train this not on ideal body types, but regular people, people like you and me. And we did that, and we used Hollywood motion capture technology, the same technology that you see being used in filmmaking around the world today. I should say Hollywood in Taiwan, of course you have a major film industry in Taiwan too. That technology, motion capture technology, is a great way to capture all that training data. But now I've got an enormous amount of data, an enormous amount of depth video frames, and I need to train my algorithm and make my algorithm work. So this is a non-trivial machine learning problem. I actually had to, in Microsoft Research, we had some technology called Dryad Link. You can get access to this technology today yourself, and it's a way to do a very large distributed processing in an efficient way, to program that efficiently. It works in a big cluster. We still run this cluster today because we're constantly refining this algorithm. We're constantly tuning this algorithm. We make this available through updates to the Xbox, and now through updates to the SDK. So as being part of this SDK, you get access to this latest algorithm work, where we constantly refine this algorithm. Don't forget the audio. It's not just about the vision system. There's another research paper and work on this. There's an extensive parallel set of work. The primary researcher here is Ivan Tashev in Microsoft Research Redmond, where I'm based. He did a really beautiful presentation. It's a 1-hour presentation, so it saves me an awful lot of time talking about the audio algorithm. If you just go and download this presentation, it was done at MIX, the Microsoft conference that happened in April this year. And that talks all about the audio pipeline. So there are 4 microphones in Kinect, and it's one of the nicest microphone arrays you can buy. It's very inexpensive. You get a free Kinect with a microphone array. There's another way to think about it. You can use this 4-element, I'm going to say elephants again. I saw a lot of elephants in another place, but 4-element microphone array. And you can do interesting things because it's a microphone array. You can do things like doing echo cancellation. You can do noise suppression. And you can do things like beamforming to determine the direction of where a sound is coming from. This gives you an enormous amount of power to you as researchers or practitioners, students, whatever, to do your own work in the audio space. Really powerful audio array. So check out that deck. It's nice and technical. It's a good deck. Let's talk about where we're trying to give this technology to you. We have an SDK available. And we wanted to make the SDK available for months. Personally, I got involved in the summer of last year, so I've been working on this almost 18 months now. You can go read another version of this story that's published in Wired magazine. The URL's up in a strange way on the right-hand side of the screen here. But like many stories that are complicated and have lots of different people in, there are many different ways, and many different vignettes, many different types of story that happen. I won't go into the whole of my story, but the details are that many people were involved in getting the Kinect technology out, not only to the Xbox community and people playing games, but another group, a large group of people in Microsoft Research and in Xbox itself, helping to get an SDK out to all of us. After the Xbox product was launched in November, we were working really fast to get an SDK out. The community was even quicker. So the community got into the Xbox, they built their own drivers. It was amazing to see. People got on and built all sorts of interesting applications while we were working on our official SDK. We worked as hard as we could, and we had our top executives. Craig Mundy is the boss of MSR worldwide and a whole bunch of other business units. Don Matrick is the head of Xbox and all the other entertainment businesses in Microsoft. So these 2 top executives, reporting to Steve Ballmer, they committed us to build an SDK for all of you in February this year, 2011. And they said it would be available in spring. And so we were working hard in Microsoft Research and in Xbox, but particularly Microsoft Research in this case. And finally we made it in June, in the last few days of spring this year, and we released the Kinect for Windows SDK Beta 1, the first beta, in June 16th. Since launch, we are evolving this technology, and we're in transition to the product group to make this a full product. Microsoft Research was just helping out temporarily because we wanted to get this out in particular to students and researchers and professors around the world as soon as possible. We've already had a beta 1 refresh in August. Excuse me. We released beta 2 in November. That's also the first anniversary that the Xbox product was released. So it was just a nice correlation. The full commercial release of Kinect for Windows is in early next year, early 2012. Not spring, early 2012. But it may be, I don't know, the last few days of early. I'll leave you to determine which day that is. We haven't committed to another date, but as soon as possible in 2012. You can track the progress of the product group, because it's no longer Microsoft Research doing this work. It's the product group in Xbox that are doing this. They're not just doing it for Xbox, they're doing it for Windows, for all sorts of different applications. And it's also not just for academics and students this time, this is for companies. If you want to start a company, or if you want to go and work for a company, or if you want to build a new business on Kinect for Windows, you can do that from the start of 2012, early 2012, because we will have this technology available commercially. So a little bit of history. This was the original website that we put up as our teaser before we launched. Some of you will be familiar with this. If you've already downloaded the SDK, this is what we launched in June. But this is what you'll see today. And this is our new brand, Kinect for Windows, from the Xbox product group, which are behind this full commercial product, Kinect for Windows. And it includes not only the software in the SDK and all that artificial intelligence software, the video and the audio and so on, it also includes some new hardware. Now the new hardware won't look dramatically different to the current hardware. But it does have some interesting features. For example, it has a near mode, which allows you to get closer in to see the nearer field than the old Xbox technology. So that's really useful for Windows scenarios, because if you remember, the original Kinect is designed for a living room, for playing games in a living room. So the distance range is suitable for a sort of what we call the 10-foot or the 3-meter experience. But often in Windows, I want something closer in. I want to be nearer the computer. And so it's important that we have a Kinect that can look further in. And this now works up to half a meter, 0.5 meters. And it even goes gracefully degrades out to 0.4 meters. So it's much closer. Go back to the SDK. What's in the SDK? We have access to the raw sensor streams. You can get the raw data. You don't have to deal with the human body tracking if you don't want that information. You can just use Kinect as a sensor, both a video sensor or an audio sensor. You don't have to use all of the features at one time. And you can build all sorts of interesting applications just using parts of the Kinect device and the Kinect technology. And we give you that access to the raw sensor streams in audio and video. You can use the full skeletal tracker, and you can stand on our shoulders and use all of that training information that we've spent collecting around the world, tens of thousands of people, training the algorithm. You can get access to that with a skeletal tracker. And we're refining that all the time, as I mentioned earlier. So by getting on board with the official SDK here, you can benefit from our refinements as we make it available to tens of millions of Xbox users. Now we're going to make it available, the same algorithm, the same refinements, to all of the people building on Kinect for Windows. You can get access to all the advanced audio capabilities. I'll let Krishna tell you more about that. He has a really nice demo for that. We've got sample code. There's plenty of sample code available today. You don't have to start from scratch anymore or just use Krishna's tutorial. You've got, now there's over 100 samples available on our project gallery. So there's some built-in samples to the SDK, just a small number, get you started. They're quite easy to use. But there are now over 120 effectively projects that you can use as samples on our project gallery. It's easy to install, it doesn't take tens of minutes, it doesn't take gigabytes of files. It's initially for non-commercial purposes, initially for education, initially for hobbyists and enthusiasts, although we will allow early prototyping to happen in companies, because ultimately we want this to be a commercial product. We already announced that we're working formally with 200 companies around the world in I think it's 20 different industries and 25 countries that are officially working with a preview for the commercial SDK. It works on Windows 7. It does work on Windows 8 as well. I keep on forgetting to update that, but of course it works on Windows 8. Windows 8 will be our future version of Windows. You can use C++, you can use C#, or even Visual Basic. And primarily Visual Studio 2010 is the development environment. There's more information on the website to check that out. There's access to a whole set of training material. Not only is Krishna going to give you a taste, if you haven't tried it already, but you can get access to videos from when we launched the technology in June. It's on the Channel 9 website. Channel 9 is a great community website supported by Microsoft, run by Microsoft, and they helped launch the Kinect technology. It was a really great experience working with them. They also have a site called Coding for Fun, also part of Channel 9. Coding for Fun is our project gallery. When I copied and pasted this picture, there was only 15 projects on that. This was many months ago. The latest one is 120, so I think it's 128 projects. And we asked that these projects have source code as well. So these are where you can get access to many, many different samples. This is not all built by Microsoft, very few of these built by Microsoft. These are mostly built by people like you, built by the community, people that are exploring what you can do with the Kinect for Windows SDK. So do check out this site, but I also invite you to participate. If you have an idea, if you would like to see your project on this site, then it's very easy to do. Just email us. So we were also almost creating a movement here, a community of people that are exploring the Kinect technology and applying it to all sorts of different scenarios. Some of them are natural user interface. Some of them are about novel user interfaces that are perhaps more natural for us to enjoy, like the original design of the Xbox and its entertainment experiences. But some people are using the Kinect as a sensor array and using just the video or just the depth stream or just the audio stream. So very interesting combinations, but lots of excitement happening. I hope you'll be part of this movement too. We even have a little video that you'll start to see less commonly now, because this was part of the Microsoft Research Days as we were just getting started with the Kinect for Windows work. And we saw this as a movement that changed, not only with Microsoft people, but everybody that gets access to the SDK, people like you. So I hope you'll be part of this movement. Let me explain what some other people have been doing in the community. So we launched in June. We had a 24-hour coding marathon, sometimes called a hackathon, all sorts of other names. But 24 hours, not everybody went to bed that night because it was 24 hours. We brought in a bunch of students and industry people to see what we could do in 24 hours with the SDK. Sight unseen. They'd never seen the SDK before. I'll have a slide on that in a second, let me tell you more. And in the first few months, we've started to do talks like this one. Go out into the community and share with you both our excitement, hear about what your ideas are, hear about some of your projects that you've been doing. I hope we'll hear some today, and I encourage you to ask questions and highlight that at the end. But we've visited all sorts of places around the world, and here we are today in Taiwan. The Code Camp, the hackathon that started on the launch day, was quite remarkable. We had a bunch of universities and industries, as I mentioned. I think there were 36 people total. A little story from here I'll explain. Of the 12 demos that came out of this, people formed teams of 2 and 3. Of the 12 demos, one demo was even produced by a team of students, a couple of students that had never programmed in Windows before. So now, they're pretty good students, I'm sure, but it was still remarkable to us that not only had they never programmed in Windows before, but like the rest of them, they'd never seen Kinect for Windows SDK before either. And yet in 24 hours, they built a really nice demo. And this is something that we've seen reproduced. As we've been talking around the world, as we've been hearing about your projects, people are finding this technology relatively straightforward to use, remarkably easy to pick up. And so I encourage you today to, if you've not downloaded the SDK, try it out for yourself. It's a fun technology to work with. And it's really easy to get started, build the samples. Even if you stop there, it's still a part of the experience of the leading edge, the bleeding edge of computing science today. Well worth trying, well worth experiencing. The project gallery on Channel 9, over 120 projects I mentioned today. I would love to do a talk which just went through all of these projects because they're all interesting in different ways. And I'm really glad that our colleagues here in Taiwan showed some videos from the projects because they showed some of the projects there already. So that saves a little bit of time. So I won't go through the 120. There'll be no time to hear Krishna if I did that. But do check these projects out. If you're stuck for ideas, if you try some samples, you're not sure where to go, it's really good inspiration. If nothing else, check out these projects to see all the sorts of different ideas, all the different applications that people are doing. Just amazing creativity is happening in this space. And you can be part of that. I'm sure you have ideas to contribute to this too. So do submit your own ideas. Send in your projects. Get your name in lights. One of the things that's very cool as part of Microsoft is that we have we're a big company and we reach a lot of people, talk to a lot of different people. If you use the SDK, the official SDK, and build applications using this SDK, we would love to highlight your work. So as we go talking to people about the projects around the world, then we can highlight your projects too. So do send in your ideas. The next steps, we have some contests, particularly for students. Kinect is part of Imagine Cup this year. Imagine Cup is the big student competition, undergraduate students. It's going to be, the finals are in Australia this year, so quite close by. Last year it was in America, it's been around the world. We have some pre-university work as well, starting in the US in this case. I get a little nervous about Kinect and technologies being used before university level, but the best high school students definitely like to use the SDK and sometimes are better even than some undergraduates. They can use the SDK. It's also a testament to how straightforward this technology is to use. And we're using this in robotics, which is a very common use of Kinect today, using it as a sensor array. We're also, in this case, using it as a natural user interface. And I encourage you, if you have a robot interest, robot projects, check this out, how we're using Kinect in the first. There's also local contests, and I wonder if there's any local contests in Taiwan. But many countries are doing their own local competitions, so I encourage you to think about that. It's a great technology for getting people together, building a contest around it. It's just so interesting, so exciting. We're doing these training workshops around the world. I'm interested in feedback from my colleagues and from yourselves about what sort of classes you would like to see. I'm sure your professors would like to hear that if you're a student here. And the big thing that's coming is in the new year, early 2012, is the commercial release, where we're releasing not only an ability to have companies use this technology, sell products based on it, build new businesses on it, but there'll be new features and new hardware coming. So that we're really upping our game, really transforming this technology. This is not a technology that Microsoft Research has put out as an experiment, and maybe it'll work, maybe it won't. It's up to you now to use it. This is a technology that we're behind. We see this as transforming the way people interact with computers and maybe used as interesting scenarios that exploring new product types that we've not even thought of today. So very, very cool technology. A movement for change. Be part of that movement. Come join us if you haven't already. This is the logo to look out for, the new Connect for Windows logo. ConnectForWindows.org is the website. Ignore the website of my t-shirt, that's the research one. That's the website to go to. This one will get to the same place, so it's not that confusing really. Let me pause there. I'm open to questions, then we can hand over to Krishna. Thank you very much for your time today. Is that a question coming? No, just camera. No questions. I have a question. Yes, at the back.
Excuse me, I have a question. There is another SDK, for example, OpenNI, which can also apply on Kinect. What is your opinion about the Kinect SDK from Microsoft and the OpenNI library?
Thank you. So I'll repeat the question for the video and so on. The question is asking about another SDK from OpenNI. And this is a legacy, particularly of the window of opportunity that there was while Microsoft was working on its official SDK, where the community itself saw the potential of this technology and wanted to make available this technology to everybody. So I can really only speak to the official SDK from Microsoft. And the Kinect technology, the Kinect hardware, is from Microsoft, and therefore the SDK that we've released is the one that I would recommend. I also think that we are showcasing the best work that we can of our own work, particularly on the algorithms around the skeletal tracking. You'll also see us add new features. I can't get into all of those features today, but there are some top asks from the community about what things they would like to see in facial recognition and gestures and all this sort of thing. We see this as very serious business because we want to make a success of this from a commercial point of view. We're not just playing around, it's not just researchers sharing a cool work. The purpose here for Microsoft is that we're very serious about making this successful. So I recommend our official SDK. I think there's great work being done by the community, and I respect that nicely. I think there's room for open source approaches as well as closed